Good morning, my Algebra 2 students. I hope you guys are having a great day and are ready to learn something new and pretty easy peasy lemon squeezy, I think. So today we're only going to do a small portion of this lesson. We're not doing the whole entire lesson, just a small portion of it. And this lesson is titled Theorems about Roots of Polynomial Equations. So for today, you're going to need some paper, a pencil, just a basic calculator. You need your textbook. We're going to be on page 313. And then on homework 59, today is going to come out of your textbooks. The even ones, 10 through 16. And there are only 4 problems that you have to do tonight for homework, so please make sure that you get those 4 done. And it should be pretty quick because I want to make sure you understand what I expect you to do from each of those 4 problems. All right, so we're going to go ahead and get started. All right, so we're going to teach you today. It's called the rational root theorem. So we're going to teach you today how to find a rational root. And this really isn't too hard. As long as you know your times tables or have the ability to use a calculator to see if something is divisible by something, I think you guys should be okay because these numbers aren't going to be exceptionally large, and I think you should be just fine. All right, so finding a rational root, there are things that we need to know in regards to our problem. So we're going to go ahead and give you a problem, and then from there we can identify the parts I'm looking for. All right, so we're going to start out with the problem 2x cubed minus x squared plus 2x plus 5 and equals 0. And I know this could look at this and be a little bit daunting at first and maybe a little bit scared, a little shaky in your boots, but I don't want you to be shaky in your boots because I have 100% confidence you can do this. All right, so the first thing that I want you to be able to identify is your constant. That's the very first thing we have to identify up here. So up here in this polynomial expression or equation, what is our constant? Who thinks they might know? Lainey. That's right. My constant is 5. Beautiful. So my constant is 5. I'm going to put in parentheses 5. All right. The next thing we have to know is our leading coefficient. Right. Who up there thinks they might know who our leading coefficient is? Leading is a really good word to help us tie this in. Okay, let's see who thinks they might know. All right, Jeremiah Pauling, who is my leading coefficient? That's right. My leading coefficient is 2. That is beautiful. Gorgeous. All right, so we've had the hard part, just identifying who is your constant and who is your leading coefficient. All the other numbers, they don't matter to us right now. We do not even need them. They're just there for the show. All right, so now what we're going to do is look for factors. Factors say, what can we multiply to get the number that we're starting with? So for our constant, we're starting with 5. What numbers can you multiply together that make 5? Those are their factors. So what are the factors of 5? That is right, Alex. My factors of 5 are 1 times 5. Beautiful. 1 times 5 is 5. Is there any other way we can get 5? You're correct. There is not. That's the only 2 numbers that multiply to make 5. 1 and 5 that are whole numbers. All right, so leading coefficients. So, Christian, what can I multiply together to get the number 2? That's right, 1 times 2. Beautiful, beautiful. All right, so now we're going to teach you a formula for finding possible rational roots. So, formula. And this is for finding possible rational roots. All right, so our formula defining possible rational roots is going to take everything that you just have used right here, and we're going to use it right down here. I think you guys so are amazing. Okay, so to find the possible rational roots, we're going to take the factors of the constant we know the factors of our constant. They are 1 and 5. Beautiful. And we're going to divide them by the factors of the leading coefficient, in which we have the factors of our leading coefficient are right there. Isn't that awesome sauce? So now, we're going to go ahead and we're going to list, we're going to take, to find these factors, this answer would be just like this, and it would be plus or minus. So it could be plus those values or minus those values. I'm going to go ahead and move this screen up a second. Alright, so what we're going to do is find some possible roots first. So start finding our possible roots. Alright, start it out. We're going to take each individual factor from the constant and divide it by each individual factor of the leading coefficient. So my first factor of my constant is 1. And I want to divide it by 1. So 1 divided by 1. Then I'm going to take the second factor of the constant, which is 5, and divide it by 1. So 5 divided by 1. Now I'm going to take that first factor, which is 1, of the constant, and divide it by the second factor of the leading coefficient, which is 2. 1 divided by 2. Then I'll take our second factor of the constant and divide it by the second factor of the leading coefficient. So 5 divided by 2. So now my final answer, we're just going to write plus or minus 1 time. So you don't have to write plus, minus, plus, minus, plus, minus, plus, minus. Just write it 1 time. And we're going to reduce. 1 divided by 1, well, that's 1. 5 divided by 1, well, that's 5. Can I reduce 1/2? Nope. So it stays 1/2. And can I reduce 5/2? Nope. That becomes 5/2. So this is how we'll write them for homework. When we start to do stuff online we'll spread them out. Online we'll write them plus or minus 1, plus or minus 5, plus or minus 1/2, and plus or minus 5/2. This is how they'll write them online. But for me, for homework, if you just put the plus or minus out here, that's like distributing, and I know that's what you're meaning. But if you want to write it like this, that's fine. So we're just looking for the possible roots. So either you can write your answer this way, or you can write your answers this way. Either one is fine. These are okay, but that's what we're looking for. Alright, so we're going to go ahead and turn in your books to page 316. I'm going to do the odds with you, and you'll do the evens for homework. So that way you have something to kind of figure out what I'm looking from you for, how I want you to set your homework up. Alright, so here we go. Alright, so we're going to go ahead and start with number 9. So the first thing I want you to do on your homework is write down the problem. So when you do your homework, write this down. This is page 316. You're going to write down the problem. So x cubed minus 4x plus 1 equals 0. That's the first thing I expect you to do. In order to get credit for this assignment, you must set it up the way I'm showing you. If you don't, I'm going to feed you back and say, sorry, try again. Alright? I want you to be able to identify your constant, and I want you to be identifying your leading coefficient. Alright? So who is my constant up here? Jeremiah Burton. That's right, my constant is 1. Who is my leading coefficient? That's right, Raina Smith. There's a 1 here we do not see, so my leading coefficient is 1. So if you need to write the 1 in when you don't see it, make sure you put it. Alright, the next thing I want you to do is you're going to draw an arrow, and you're going to list the factors of that number. So what are the only way we can get 1? That's right, Coco, 1 times 1. Since the only way we can get 1 is 1 times 1, and 1 repeats itself, we only list the factor 1 time. So with that being said, it means that the factors of the leading coefficient would also be 1 because they were the same number. Alright, so next thing I want you to write is right below, you're going to write possible roots. So possible roots. Alright, so from here, this is where we're going to take the factors of our constant, which is 1, and and we're going to put it over the factor of the leading coefficient, which is 1. And then we're going to come down here and show everything being reduced. So 1 divided by 1 is 1, so plus or minus 1. Or if you just want to write plus minus 1. Either one is fine. So either this answer or this answer will be okay. Alright, everybody doing okay so far? Alright, we're going to do number 11. And again, we're going to show you again what we're looking for so you can understand there'll be no discrepancies. Number 11, write the problem down. So 2x cubed minus 5x plus 4 equals 0. Alright, so what's the first thing I need you to identify? Lainey. That's right, I need to identify the constant. So Lainey, who is my constant? That's correct. My constant is 4. Alright, so Lainey, what can I multiply to get 4? That's right, 1 times 4. Anything else? That's right, 2 times 2. So now, I only wrote the 2 one time because that's a factor that repeated itself. Like when 1 repeated itself, we just put 1. We didn't write 1 and 1 because we don't write 2 and 2. Just write it one time. Alright, what's the next thing I have to identify? Geo. That's right, I can identify my leading coefficient. And my leading coefficient, Geo, is? That's right, 2. Alright, so Alex, what can I multiply together to get 2? That's right, 1 times 2. Beautiful. So now what's the next thing I need to find? Jeremiah Pauling. That's right, possible roots. Alright, so I'm going to review this possible root section again. To find possible roots, we're going to take each individual factor of the constant and divide it by each individual factor of the leading coefficient. So I'll take the 1 and divide it by the 1. Then I'll take the 2 and divide it by the 1. Then I'll take the 4 and divide it by the 1. Then I'll move over and take the 1 and divide it by the second factor, which is 2. Then we'll take the 2 and divide it by the 2. Then we'll take the 4 and divide it by the 2. Alright, then we're going to do plus or minus, and then we're going to reduce these guys. Alright, so now, what is 1 divided by 1? Correct. 2 divided by 1? Correct. 4 divided by 1. Beautiful, beautiful, loving it. And can we reduce 1/2? Nope, you're right, we cannot. 2 divided by 2, what does that become? Ooh, 1. I already have 1, I don't have to list it again. Okay, what about 4 divided by 2? What does that become? That's right, 2. I don't have to do it again, so now I'm done. There is my final answer. Alright. Everybody doing good so far? Alright, we're going to move this up. We're going to do number 13. Alright, number 13, we got 4x cubed plus 2x minus 12 equals 0. Alright, AJ, what do I need to know first? That's right, I need to know my constant. Alright, AJ, who is my constant? That's right, it's 12. AJ, I hear you say that's negative 12, which is right. But when we're trying to find factors, we don't need to find factors of negative 12 because we're doing positive and negative in the final answer. So just go ahead and give me the absolute value of that. We'll be fine. Alright, so Tyler Vanderzee, what can I multiply to get 12? Yep, 1 times 12. Anything else? That's right, 2 times 6. Anything else? That's right, 3 times 4. Now you can put yours, you don't have to put them in order. I just like to put mine in order. But you can put yours in any order that you want. Okay? Alright, so Lily, what do I need to find next? That's right, I need to find my leading coefficient. Alright, Lily, who's my leading coefficient? That's right, it's 4. Alright, Mackenzie, what can I multiply to get 4? That's right, 1 times 4 and 2 times 2. And we've already did that one above, right here. 1, 2, 4. So sometimes you're going to repeat things. You already will have them written down. You won't have to think too hard for them. They'll be right there for you. Beautiful. All right, so what's the next thing we need to do, Gabriel? That's right, possible roots. All right, so Raina Smith, give me my first set of possible roots. Okay? She said she was going to take each of these constants and divide them by 1. So she's going to put every one of these guys over 1. 1 over 1, 2 over 1, 3 over 1, 4 over 1, 6 over 1, and 12 over 1. Alright, now what will I do, Christian? Yes, I'm going to take all of these numbers up here and divide them by 2, or put them over 2. So 1 over 2, 2 over 2, 3 over 2, 4 over 2, 6 over 2, and 12 over 2. Alright, what will I do next? Jessica. That's right, I'm going to take all of these numbers and put them over 4. So I got 1 over 4, 2 over 4, 3 over 4, 4 over 4, try to squeeze these in, just 6 over 4, and 12 over 4. Alright, let's see if we're trying to squeeze all them in there. So now we're going to find our plus or minus and our final answers. So we're going to reduce. So let's reduce these guys right here. Anything divided by 1 is equal to itself. So Cornelius, what will be those first answers there? Yes, there'll be those 1, 2, 3, 4, 6, and 12. That's beautiful. Now let's start looking at our refractions. If they reduce, and they reduce to 1, 2, 3, 4, 6, or 12, or something else down the line, we don't repeat them. So remember, we don't repeat the factors or the possible roots. So can we reduce 1/2? Nope, stays 1/2. 2 divided by 2? That's right, it's 1, so we don't repeat it. Can we reduce 3/2? Nope, so it stays 3/2. 4 divided by 2? Well, that's 2, so I have to repeat it. 6 divided by 2? Well, that's 3, so I don't have to repeat it. 12 divided by 2? Well, that's 6, so I ain't got to repeat it. So we're going to move to the next one. 1/4, which we can't reduce, we leave it 1/4. 2/4 is 1/2, which we already have. Then we got 3/4, which we can't reduce. Then we have 4/4, so 4 divided by 4 is 1, we don't repeat it. 6/4 reduces to 3 over 2, which we already have. And 12 divided by 4 is 3, which we already have. So this would be your final answer, unless you want to write them out individually with a plus minus in front of them. That's totally up to you. All right, so that is all that we're doing for our lesson today. So that's all you have to do for tonight's homework, is label them just like this: the problem, your constant, your leading coefficient, what they are, the factors, all the possible roots, and then which ones, when you reduce them down, what will be they become. All right, have a great day, and hope you guys do well.